Good.
Hi, my name is Olusegun Maikala. Today I'll be demonstrating the implementation of remote access VPN solution designed for Faraday Bank. This is a few details of the company. The name of the company is Faraday Bank. It's a startup company with 20 employees and 2,000 users. They specialize in account services, online banking, mobile banking, mortgage and insurance. The business objectives for the VPN implementation is low cost of implementation. They've got £30,000 budget, high performance VPN, the bank web server must be accessed via a secure medium, ease of configuration on employees' devices. The VPN must offer high security and ease of management. So in order to successfully cover the most prioritization, I needed to add a successful ping, internet access from any device to the server's IP address. Next one is to configure PPTP, HTTP, IPsec, OpenVPN on the server. Now, the other task that must be covered under most prioritization is the configuration of HTTP, IPsec, OpenVPN, PPTP on both Ubuntu client and Windows client. So, having covered that, I had to configure the PPTP client, HTTP, IPsec client, and OpenVPN client on Android devices, iOS devices, and my Mac OS devices, which I successfully implemented. The cool apps are the performance testing of PPTP, HTTP, IPsec, OpenSSL using Apache benchmarking, and attempt to break PPTP challenge handshake using a password testing tool. However, I was not able to break this due to the time constraint. The network diagram for the project implementation. This side represents the remote users on network. This side is for Ubuntu users, 192.168.20.2. And this is for Windows clients, 192.168.20.3. This side is it does represent the wireless users device. The DHCP is issued from here for all wireless users, so they can easily access the network without physically connecting to the network. So this side does represent the tunnel through which the packet flows. Now, on the other side, we have the VPN concentrator, which is the BIOS router. It does function as both the router and the VPN server. So I gave it an IP address of 192.168.10.1. So on this side we have FTP server with the IP address 192.168.10.2, and this side is represent the Aperture web server of 192 using the same IP address as the FTP server 192.168.10.2. And right here we have DNS server using Windows Server 2012. Right, so this is a complete network diagram for the implementation. Now, this is the implementation of the project. On this side, we have the server, file server, and towards this side, we have the network representing the clients and wireless users. This yellow cable represents the WAN connection between the server side and the client side. This is the access point used to extend the internet network to the mobile users. So I used two adapters to connect the internet network of Faraday Bank and the network that goes out to the internet So this VMnet 1 represents the internet network 192.168.10.0, and the other one goes to the internet. The IP addressing will be shown later on. So as discussed earlier, we have two VMnet adapters. The first one is 80. So I assigned an IP address for the default gateway on that adapter. The first one 192.168.10.0, the 10.1. So the second one, for the link that goes to the 1, I assigned an IP address 10.2.0.1. This is the VPN PPTP VPN configuration on the server. The credentials shown, the first one test user, the second one test user 1, is used to represent the credentials that will be needed for the PPTP connection. So this is how it is set up: the remote access authentication and the client IP pool. The client IP pool is the IP address pool that will be assigned to the user connected to the PPTP server. The outside address is the same IP address used for the WAN connection. This is the address that listens to any PPTP connection coming in from the user. So this area represents the client side. The first adapter is VMnet 1, which represents the internet network for the client, 192.168.20.0. The second one is the PCIe, which represents the link that goes to the WAN connection. The third one is the adapter added to the extended to the access point, which will give access to the wireless users. As said earlier, this is the Ethernet 80, which represent the VMnet 1, the network 192.168.20.0 for the internet network users. So this is the default gateway configured for the VMnet 1 80 network. So this is the IP address configured on the link that goes over to the WAN connection 10.2.0.2, and this is the default gateway for all wireless users trying to connect to the internet network 192.168.3.1. Just before we go on, I would like to show the IP address configured for Ubuntu. As you can see on this, we configured it to have 192.168.20.2 IP address. This is the IP address of the server on FireBank, the PPTP server, 192.168.10.1. To ensure that we can connect to the server, I will first ping the IP address of the server. So this shows us that we can connect to the server. I'll stop that. So now we want to see how our PPTP client configuration is done. So I will navigate to Chat Secret to see the username and password we imputed into it. So I will do sudo nano Chat Secret. So this shows the username and password entered for the Ubuntu client to connect to the PPTP server. The script required for connection to the server is in myTono script. So I will sudo nano myTono. So this is the configuration required to connect. So I will try to connect to the server now by issuing sudo pon my_tono. So we will say in a few seconds that we are able to connect to the server. So this shows the that we're connected. As you can see, we have PPP, point-to-point protocol compression, and GRE Generic Routine Encapsulation Protocol. Now we are on the Windows client. We want to see if we can connect to the PPTP server. I will first ping the PPTP server address 192.168.10.1. This shows that we can connect. So I will go back to the PPTP properties on Windows. This is the IP address of the server 10.2.0.1, and the security used is CHAP, Challenge Handshake Authentication Protocol. So now once that is done, I will go over here and click on PPTP connection. So this asks me for the username and password, which I will enter. I will enter text user1 and the password. Now I will click OK. While doing that, I will try to listen on Wireshark to see if there is any connection. So I will click OK. Click OK. Alright. So it's connecting now. So we are connected. In order to verify this, I will click on View Connection Properties. Oh, sorry. I will click on alright, View Network Status. Click on that. So this shows that we're connected right here. Details. So we were given an IP address 192.168.150.102, which was already shown in the service configuration. So we will go on Wireshark to verify our connectivity. This is the request from the client, Windows client, to the server. So as we can see here, this is the control connection request using PPTP port 1723, which is required for the control. So the next in line is the configuration request between the server and the client. So once that is verified, there will be generic routine encapsulation to encapsulate the packet. Bear in mind that the IP address of the Windows is 20.3, which we will check now on our Windows client. So I will go over here, right click on this, okay, click on this, properties, IPv4. So this shows the IP address of the Windows to verify that the connection is coming from Windows. So this is an Android phone. I want to connect to my VPN server, so I will enter the credentials needed. And the password. So I will set up a connection, PPTP connection. As you can see, we are connected. So looking at our Wireshark, we can see that this Android phone is connected to the PPTP server. So you can see this echo request, echo reply, and to show that we are connected as well, I can, let me see, right on the camera is a little blurry. Okay, this shows we are connected. So this is an iOS device used to set up a connection from the iPhone to the PPTP server. This is the service address and the credential needed. Now I'm going to set up a connection to the PPTP server. So we just track that. So this shows we're connected. And as it can be seen on the Wireshark, it shows there is some communication going on between the server and the client 3.19. So to further verify that we're connected, I'm going to click on this information. Okay, I'm going to click on the VPN information. Okay, this shows us that we're connected with the assigned IP address 192.168.150 from the server. So now I'm on the server side. I've already configured the HTTP IPsec. So to verify that the HTTP is configured, how we do show VPN HTTP. Now we can see the credentials assigned for the HTTP VPN. We have 3 credentials there, and the client IP pool for IP addressing pool for the internet incoming connection for the users. Now, as we all know, HTTP doesn't have its own encryption and authentication. It solely relies on IPsec for its tunneling. Now, I'm gonna issue show VPN IPsec to verify that we configured our IPsec tunneling for a secure HTTP connection. Now, this is ESP group configured for IPsec. Is required for encapsulation of our data. Now, the second one is IKE group, which stands for Internet Key Exchange, which is basically the IPsec Security Association needed to secure the connection between the client and the server. Now, if we look at the IKE group, we would see 3 technologies there: the Diffie-Hellman group, encryption, and hashing. The Diffie-Hellman is used to create session keys. It is added to the secret keys configured in IPsec. It is used to further increase the algorithm used in the session key. Now, in show VPN HTTP, we can see the pre-shared key right here. Pre-shared secret text. Secret text is the pre-shared key used in IPsec authentication. It's right under IPsec settings. Now, as discussed earlier, the DH group and the encryption used is used in further in creating session keys out of the secret pre-shared key. Now we are right on the client, Ubuntu client, to configure our IPsec connection. Now, in order to verify that we rightly configured this IPsec connection, I'm gonna go into ipsec.conf, etc ipsec.conf. Now, right here, this is very crucial for a successful IPsec connection. We'll see here that we have various inputs here. The first one is OAuth, which is authentication, and the second one is PFS, perfect forward secrecy. This is needed to further increase the cryptography used in IKE exchange. And the next one is key tries, to further keep retrying keys in case of any change in server's IP address. IKE lifetime is needed for to increase to after this specified time, which is 8 hours, then we will have to renegotiate our IKE. So all these are really needed, most especially the IKE proposal. We'll see right here that we have different proposals ranging from AES 128 to it's quite a lot, to 3 days, and our hashing value we could use MD5 and SHA-1, and this is modulus P, which is Diffie-Hellman modulus, to further increase the session keys generated from the pre-shared key. Now, we really when I issued the same key, the same encryption algorithm used in the server, I realized that I couldn't pass the mail mode simply because the server is not accepting the proposal from the client. So I needed to increase enter all possible proposals used in IPsec. So when I did that, I realized there was a successful connection. Now this is the encryption used in IPsec. So as you can see, I have various proposals for that. This is the first one, which is IKE, is required for the main mode, and the second one is the quick mode. We will check that later. So in order to enter the same secret key we used on server on our Ubuntu client, we have to go into ipsec.secrets page. As you can see here, we have secret test, the same pre-shared key entered in the server. Now, right on my Ubuntu client, I want to connect to the server. I've already opened up Wireshark to see if the connection is successful. Now, I will have to go to edit connection. I'll enter my credentials. So we're right on the HTTP IPsec connection. This is the server's IP address, and we have to enter the credentials needed for IPsec access. Now, I will try to maintain have a connection from the client to server, and then I'll briefly explain the handshake occurred in the connection. Now I'm trying to connect. As you can see, it's trying to get into the server. We'll wait for that a few seconds. While we are doing that, we realize that there is some communication going on. I will briefly explain that after the connection is set up. Now we can see that it is connected to the IPsec server. Now I will click on connection information. Now we can see that IP address is signed out by the server to the client. Now I need to explain the authentication that occurs between the client and the server. Now, as we can see, this is the IP address of the client, the IP address of the server. So this is main mode. But what happens before main mode? We have something called we have something called ISOCOMP association. Now, this happens when clients initiate the IPsec process by sending a proposal policy to the server, and then it negotiates an IKE, which is otherwise known as ISOCOMP, main mode phase 1 exchange. Now, the next step is main mode. In the IKE phase 1, which is otherwise known as main mode, server looks up its proposal to match the proposal sent from the client. If there's any matching proposal, the server responds to the client by confirming the policy. Diffie-Hellman could be used, as seen in DH group, which we entered in the servers, to further increase the generated session key strength, which is generated from the pre-shared key between the servers and the clients. Now, if everything is done quite okay and both of them could generate the keys and decrypt at the same time, then we moved over to quick mode, which is the phase 2. Now, quick mode occurs after IKE established the secure channel in phase 1. Now, quick mode is used to generate more shared key material to prevent replay attacks. Now, in this phase, periodic renegotiation of IPsec SS policy occurs in this mode when the lifetime expires. Remember, our lifetime is 8 hours. When it expires, then they could renegotiate the IPsec SS. Now, if we enable the perfect forward secrecy, then it is specified in this mode. This is used in further strengthening the Diffie-Hellman session keys generated from the pre-shared key. This is used majorly in a large organization to prevent eavesdropper or NSA or crypto analysts from analyzing the packet being sent. This is an iOS device with IP addressing. IP address generated from handed out from DHCP server configured on the router. Now we will try to connect to our IPsec VPN from iPhone. Now I will click on more information to verify that the right credentials was entered. Now we have the server's address, the account name, the password, and the secret key, the pre-shared key needed to establish the connection. Now I will try to gain access into our server, into our VPN server, using HTTP IPsec. Now I will drag this towards the right. Now it's seeking to gain a connection now. As we can see, it's connected right now. So we click on more information. This shows the assigned IP address from the server 192.168.100 to the client. So we move over to Wireshark to verify our connection. So as we can see now on Wireshark, we see 3.19, the IP address of the iOS device, attempted to gain connection to the server's IP address from main mode, quick mode, and the encapsulation process. So this is an Android device connected to the wireless network 192.168.3.14. So I'll click on this. Now before we do that, I will click on edit network to see we rightly edited the right thing. Now the IPsec pre-shared key entered is the same pre-shared key on the server. So I will click on this, enter my username, user 2, and the password. I'm just gonna connect now and see if there is any connection. Now it's attempting to connect. We can see that we are connected to the IPsec server. Now we move over to the Wireshark to see if our connection went. Now this is the information of the ISOCamp, which is the first step from the main mode to quick mode. We can see the IP address of the Android device to the server. Now this is how I configured OpenVPN server on the FireBank server. Now the first thing I did, because this OpenVPN build is based on SSL TLS certificate for authentication and key exchange. Now the process involved in building this is I installed OpenVPN on my Vieta server. So if I do highlights, these are the required function needed to build CA certificate, which is the master certificate, or we could call it the certificate authority. Now this is used in building the CA. Is called build CA. This generates the certificate meant for the certificate authority and the key used in signing either the server and the client certificate. Now once that is done, I will move over and build certificate for either server or client. For server, I will do build key server, which can be seen in the list. So for the client, I would do build key client. This is a random name. I may give it, depending on the client I want to give it to. maybe I'm giving it to Michael, I will do build key Michael. So automatically it builds the key, it builds the certificate, then it signs the certificate. Now, once that is done, because the server, the router I used is I used it to point towards the certificate and keys generated. So this is the folder I copied all the certificate and keys generated. Is in if I remember, config alt ca keys. Now if I do ls, then these are all the keys I generated so far. I generate revoke key to revoke any certificate that has been compromised, which can be seen in revoke full key. So if I want to revoke any certificate, I use this with the certificate I want to revoke. Now, for the server certificate, we have it here as VIOS key and VIOS CRT right here. Now, for the VIOS, the router configuration to point towards where the keys are, I'm gonna I'm gonna exit this to get back to the router. Now, I'm gonna show interface OpenVPN VTune 0, the interface we use to create the OpenVPN. Now, this is the configuration for the OpenVPN. The local port used is UDP 1194, which is used in listening to all incoming OpenVPN client connection. Now, the mode is the server. Protocols used, as said earlier, is UDP. Now, we can push the route to all VPN connection coming from outside. We push the route to our internal network so that they can communicate with the devices in the network. So this is the subnet given to all outside VPN connection. Now, as said earlier, the TLS, the configuration under TLS is pointed towards the CA.CRT, which is the certificate authority, otherwise known as master key. And the VIOS, the server certificate, this certificate revocation list, in case we want to revoke any certificate. Then Diffie-Hellman, which is used in creating session keys, and the VIOS key, which is the server key used in decrypting public key or public session key generated from the public client public key. Now on Ubuntu client, these are the key certificates we copy over to the Ubuntu client from the server. Now, this is the certificate. This is the master key, which is the CA.CRT, Master Certificate Authority, used in creating the keys and certificate. Now, this is the client key, and this is where the configuration. We'll make a few modifications in this. So I will do sudo nano clients.conf. So right here, we have few modifications made. DevTune, and the protocol we're using, Proto UDP. Further down, we have remote, the service address, and the port. If you want to keep trying connection to the server when in some situation when connection is not made for some reason, we're gonna use this. Then few things, passes key, keep trying the keys until it's accepted, and passes to keep trying the interface. Now that is all about it. So in order to start the connection, we are listening right now on our Wireshark. So we do sudo openvpn -config and where the configuration is. Oh, lest I forget. Okay, I will reopen this client.conf to quickly show you the the pointers to the keys. Now CA.CLT, remember we have our key stored in our certificate, the master certificate, client certificate, and client key stored in OpenVPN directory. Now we point towards the certificate and keys from the client conf. So when the connection is being attempted, then the client looks up this and points towards the files. So this is the compression. Are we going to compress our packets for some reason, which I enable compression of it. Now I want to initiate a connection. So we can see the connection is completed. Initialization sequence completed. This is the IP address given to this client from the server. Now I will go over to Wireshark. We can see here the communication going on between the client and the server. Now the first step that happens between client and server is this SSL session is established with bidirectional authentication, meaning each side of the connection must present its own certificate. Let's say the server sends a certificate, client makes an initiation to the server requesting for a certificate. Now certificate, client server replies with its own certificate, and public key, the server public key is inside the certificate, is sent over to the client. Client checks it, verifies it if it is signed by the same certificate authority that signs its own certificate. Why server sent its own certificate? It requests for the server client certificate. Now client replies its certificate once the server certificate is verified. Now once client sends its certificate to the server, it uses the public key, its public key, to generate session keys which can only be decrypted by the server. Now while client does that, the server does that as well. So both of them generate keys which can only be encrypted and decrypted by either side. Now further hash message authentication code can be done to increase the OpenSSL run bytes, which is otherwise known as pseudo random function strength for the session key generated. So after this is done, then the server and the client can now exchange their data in a secure tunnel. Now to verify that OpenVPN can encapsulate our data from the client side to FIDOBank server, I would issue Telnet. This is done while OpenVPN is not yet connected. So I will issue Telnet to the router, Telnet. Now access is gained. Now we can see there is a Telnet connection on the on Wireshark. So eavesdropper can easily access all this data. But if we use, I'm gonna exit this. Yeah. If we use OpenVPN, which is gonna be used now, sequence completed. Right. Now we're connected to the VPN server. Now I will try to issue Telnet access. Telnet access to the server. Now we're connected to the server. Now further down, we can see that OpenVPN is the only data being exchanged across the network. We can't see anything like Telnet in this, in our days, because it is encapsulated in OpenVPN. Same thing can be done using FTP access. If I do exit, FTP 192.168.10.2, which is the I'm trying to access the file server, which is located on 10.2 micro, and password. Now I can access the FTP server, but as we can see here, everything is encapsulated. So by looking at this, we can verify that our data is secure. Hi. So I'm trying to connect from my Windows client to the OpenVPN server. As you can see, we have the IP address of the server, the UDP port, and the master certificate stored here. This is the client certificate. This is the client key. So I'm gonna click OK. By the way, the OpenVPN I'm using is SecurePoint. I've tested it, it's working quite alright. So I'm gonna connect to my OpenVPN server. A second. Right, I'm gonna connect to my OpenVPN server by clicking OK. It's attempting connection. Now it's connected. I will click on that. You can see initialization sequence completed. So the next step is configuration of OpenSSL server. So we can access the server, most especially the users, the customers can access the bank server using HTTPS. So I was able to generate the certificate using Apache 2 X509. So the first step I did was install Apache 2. Then the next step was install OpenSSL. So I used a few commands to generate the certificate. So this is the command I used. If I open this, I use this simple command, very simple and straightforward. So basically it works the same way as OpenVPN, but the difference is only server has the certificates, the public key and the private key. So what happens is the client sends a hello message, which could be some random number, and TLS version is supposed, and as well as compression methods. Then the server hello message is then sent by the server with the version, random number, cipher suite, and the compression method. So once that is sent together with the certificate and is followed by the server done message, which will be shown later in the Wireshark representation. So now, when that is done, the client can respond with his key material using the public key, the certificate of the server, to generate session keys, which is used to encrypt the message sent from the customers to the server. Now, these are the items generated. Using the X509, I was able to generate the certificate. If I do sudo nano apache.crt, this is the certificate generated. So these random numbers in the certificate shows the public key, the server's public key. Now if I do exit, so the key. This is the private key used to decrypt the encrypted message sent from the client. Now we go over to the client side. So in order to access the Apache, the SSL web server of Faraday Bank, we access the IP address
from the client side. 168.0.10.2, yes, using HTTPS. So basically, because this certificate is not signed by the CA authority, so the Mozilla Firefox has a list of trusted certificate authority, and if your certificate is not signed by this authority, a message will pop up. So, like warning the users not to either to go ahead or not. So basically, since it is a self-signed certificate, I will click on I understand the risk, add exception. So I will get a certificate. Confirm. So this is the server. So this shows that we successfully accessed the server. In order to verify that, I could just go to view page info. Yes, I think so. Security, yes, and we click on view certificate. So this is the organization name, which I gave Michael, and whole unit, CNT, and the common name I gave it is 10.2. It begins on this date, and this is authentication used in signing the message for encryption. So that's how it is. Yes, thank you.
So as we can see on Wireshark, with the IP address of the client is now 192.168.3.10, and the IP address of the server, SSL server, is 192.168.10.2. So this shows the handshake between the client and the server. As you can see on the Wireshark, only the server has the certificate, not the client.